Welcome to Part 3 of Speciation 101. Here we describe how speciation occurs. Species are created when populations are separated genetically, for example through geographical or reproductive isolation. In this segment we will take you through the four main mechanisms of speciation. We will begin with allopatric speciation. This is the most common form of speciation and occurs when there is a geographic barrier causing the populations of the same species to be isolated from one another. This barrier results in a divergence of the populations through characteristics such as appearance and behavior, and usually occurs at a relatively rapid pace in evolutionary terms. Common barrier examples include streams, mountain ranges, and the formation of islands. These barriers cause populations to genetically diverge, resulting in new species. Next comes peripatric speciation. This form of speciation is a version of allopatric speciation that happens at a reduced proportion, meaning that a much smaller portion of the parent population is isolated in a new environment, causing divergence. This essentially causes a population bottleneck, reducing the genetic variation of the population considerably, eventually creating a new species. An example of peripatric speciation could be when a small population of mosquitoes is transported from the mainland by boat to a small island, and the small founding population is separated from the population on the mainland for a long enough period of time that if both populations were to reunite, they would not be able to reproduce, therefore resulting in a new species on the island. The next form I will explain is peripatric speciation. This occurs within continuous populations when neighboring populations mate with each other, but individuals at separate edges of populations do not mate simply because they will never meet. This creates a gradient in which one end of the population becomes so genetically different from the other that they can no longer interbreed. These new species no longer interbreed due to differences in niches, mating seasons, reproductive behavior, and more. An example could include a portion of a species of grass that becomes contaminated with a pollutant. This contaminated portion could diverge into a different species due to differences in its ecological habitat. The last mechanism we will be looking at is sympatric speciation. This is the most rare form of speciation and occurs without a change in habitat or geological influence, but rather genetic differences in non-random mating. This can occur when a portion of the population develops a different characteristic than another population. Examples could include exploitation of a different food source or a different preference of males by females for mating.